We've seen a variety of filters in action on our images. Now let's take a look at this code. I think there's value, even if you're not a programmer, just to understand what we're instructing the computer to do exactly. This can be done in many different languages. My preferred language is Python. And so at the top here, in lines 1 through 4, we're just importing some packages that will help us manipulate matrices and be able to do things like plot and perform some operations on images. The next thing we're actually going to do here is we're going to open the image. Okay, this is just the name of it, france.png. It's a ping file. And then what we're going to do is we're going to convert the image into basically a grayscale image. Okay, so that's just going to convert it for us so that we don't have 3 matrices, but we only have 1 matrix. Maybe I'll look at it over here. So if we actually take a look at the variable explorer, you can see that the image is a 225 by 225. But if we just run this line here, okay, I'm just going to run this over here in the prompt. Okay, that's going to import an image. Okay, and you can actually see those pixel values there. This image is actually of size 225 by 225 by 3. Okay, so that means that we actually have 3 matrices here stacked together that are each 225 by 225. So we don't want that. We actually want to make sure that we go to grayscale just so we don't have to manipulate 3 matrices separately. Grayscale is just a good starting point. Okay, now if I run it as it originally is and I double click that image, well now you notice doesn't say 225 by 225 by 3 anymore. It's just a single matrix. And these are the actual pixel values. And these colors are just really there for visualization, so you could kind of see distinguishing, pixel values. And I guess if you open this up completely, you'd probably see a very funky version of the original image. And you can tell all these pixel values are somewhere between 0 and 255. We tend to be a little bit on the brighter end, but you can see down here towards the bottom, I guess this middle portion of the image, or I guess towards the top, but like right around here is probably what we're looking at. 66 to 75, we do see that dark region. So we are getting these very low values. But as we move over past that little, I guess all that black little arch, then we start to get into some brighter colored pixels. And you can see, depending on where we are, we have some darks mixed in there. Okay, so now we're probably like right around here somewhere. And pretty cool. So you can actually see those pixel values as they are in the original matrix. All right, so that's what that does. Then over here, we're just going to basically get this into a matrix, a manipulatable matrix. So ingmat, this guy here is just going to allow us, there's really not much of a difference here, but it does give us some extra features that we can use to manipulate those pixel values with. Okay, this plt.imshow, that's just going to show the image, show img, okay, and that's just going to display that plot for us. And then we've just put in a title for that original, just so we could always be able to tell the difference, which one's our original, which one's the manipulated one. So that's just the title on the plot that you see there. Then we define this K matrix. You can ignore this one. That little hashtag there is actually commenting that line out, so that one's being ignored. Just if you didn't want to, you wanted to have lots of K matrices and not have to manipulate them over and over again, you could just have a hashtag next to the ones that you don't want to be using at the moment, and then the one that's actually in use, remove the hashtag from. But we could take this line out completely. Num rows, num columns, this is just going to return how many rows and how many columns are in our image. So number of rows will actually be 255 and number of columns will be 255. And what we're doing here is we're just creating a blank matrix. It's just full of zeros that will be the same size as our original image. And what we're just doing here is we're setting up a blank matrix, a blank canvas, if you will, into which we are going to dump our convolution results into, so that we'll have the original image and then we'll have the new image. So you can actually see here is the Y matrix. You can see that there are actually some decimals in here because we're averaging pixel values together. So this is actually just the manipulated form of IMG. And if we look at the comparison between those, first of all, notice that the outer values, the edges, are unchanged because we've ignored those. So the outline of the image will be exactly as the original image. And if you look at the Y matrix, you can see that all of the other ones beginning in the second row, second column, those are the ones that have actually changed relative to the original. So the value of 238 became 226.667. And I'm not sure how it renders the colors, because technically that's not a valid pixel value. I'm wondering if it just maybe rounds it to the nearest integer. All right, so that's all that does. Then here in these lines, this is all just keeping the outline, the edges, all the way around the image exactly the same. So in the Y matrix, this actually says all rows column 0 use the original column 0 from IMG. This is actually the last column, use the same pixel values as the last column in the original image. This is the first row, and this is the last row, and basically we're just saying, hey, copy and paste those original pixel values. Okay, here's where the actual magic happens, and this is called a loop. What we're basically going to do is we're now going to run the convolution. And here we're just going to temporarily create this variable called new y, okay, new YRC, the new y for the row, current column. This is just going to go through all of the rows, all of the columns. It's going to take the image value, so this is what we would call capital Y, and it's going to take, notice this is going to be the bottom right. So basically what this does is exactly this manipulation that we demonstrated over here. It's going to take the last Y value times the first K value, then the second to last Y value times the second K value, and sum them together. So basically this whole long string here is basically 9 multiplications all being added together. Okay, so you can take a more closer look at that if you'd like. And then what we're going to do is now in our, remember we created that blank copy, that blank canvas. At this point in our blank canvas, the first and the last column and the first and the last row have been updated in the Y matrix. And now what we're also going to do is we're going to now look at the current row, current column value, and we're going to place this manipulated pixel into that position, and that updates that 0 pixel to the new pixel value, all the while keeping the original image the same. Because remember, we don't want to operate the kernel on updated pixel values. We always want to run the kernel on the original image. So that's why we have a copy of the image, so that we don't take into account the fact that, well, now the second row, second column has been changed. We don't want that changed value to influence how we change future values in that matrix. And that's pretty much it. Then we're going to create a brand new figure. We're going to plot that new image, and that's basically what generates, every time you run this, you're going to get 2 images. You're going to get the original, and then you're going to get the convolution. So this very last line here will just show that updated. See, we're going to plot Y, we're going to plot our new image, and this is just for comparison purposes. So that's essentially how this code works. In a nutshell, not super sophisticated, but it does the trick.